the Nancy University Hospital. I'm a cardiologist and a biostatistician in the Clinical Investigation Center. Today I will explain how to perform interaction with time analysis, how to search for it, how to interpret it, and how to implement it in SPSS. So first I will make some comments regarding rates and risk, the concept of rates and risk. So a risk is a probability, it's the opposite of survival, and it's similar to cumulative incidence. For instance, a 1 year risk of 20%, it's like a 1 year survival of 80%. And it is the risk of dying during the first year. So 20% of the patients died during the first year. It's different from the rate or the hazard. Rates and hazards are based on the counting theory, and they are events per unit of time. So for instance, a rate is 5 events per 1,000 patients year. In a Cox model, we modelize the instantaneous hazard, and so it's an hazard for very small portion of time that is very close to zero. So to parallel very simple concepts, risk is really like a distance, whereas rate is really like a speed. If you travel at a given speed for a given time, you will do a given distance. So risk is really like a distance, whereas rate is really like a speed. Let's now focus on the interaction with time on a risk level, because it's more simple than trying to understand it on a rate level. So these are survival curves, and on the left panel you see that the curves are progressively diverging and that the green arrow is smaller than the blue arrow. So you don't have interaction, or at least clear interaction with time here, overt interaction with time. Whereas on the right panel here, the curves are diverging a lot at the beginning of the follow-up, and during the second part of the follow-up you have almost no effect. The blue arrow is the same size, the curves stop diverging at this point. So you have a strong effect at first and then no effect. So this is interaction with time. The effect is not constant over time. Let's analyze this on a rate scale or hazard scale. So in the Cox model we model hazard ratio. So this is the hazard and this is time. And it's a constant hazard, so A1 a constant hazard, and B1 is also a constant hazard. So the ratio of the two constant hazard is the same. We have a hazard ratio of 2 at the beginning and at the end of the follow-up. And the important point is not having a stable hazard, it's having a stable hazard ratio. We could have hazard that are not constant, but if the ratio is constant, you can provide only one association. Here on the right panel, it's a different story, very different story, because the ratio of hazard is not constant. It tends to decrease over time. You have a smaller effect here with the hazard ratio of 1.5 than here with the hazard ratio of 2. So you have an effect that is decreasing over time. You have an interaction with time. How to search for interaction in Cox model. In a proportional hazard Cox model, that is the usually used Cox model, you have a unique hazard ratio that is provided, and this hazard ratio is constant over time, but you need to test this before providing this hazard ratio. And there are basically three methods, or the three main methods are these. So the first one is the log minus log survival versus log time graph, and I will explain after how to interpret this. The second is time-dependent Cox model, and the key point is having an interaction term with time in this time-dependent Cox model, time being introduced in this interaction term as a linear variable, or either as a log transform variable, or alternatively as a categorical variable. The third option is to use Schoenfeld residuals, but it's not possible in SPSS. So I will only talk about the first two methods, that is log minus log survival versus log time graph and time-dependent Cox model. Here is a very simple SPSS example with one exposition variable, that is smoking status, death, and time to death. So those are the time to event variables, outcome variables. First, let's do a Kaplan-Meier analysis. We need to go in analyze, then choose survival, and then Kaplan-Meier. And you will need to put time to death in time, death in status, and to click on define event and define that 1 is the event and 0 is censoring. And after, you have to put smoking status in the factors section. Then you will click on option, and in option you will choose survival to have a survival plot. Very simple. This is what the output will be. So you can see that the curves are diverging. So from those Kaplan-Meier curves, it seems that there is no strong interaction with time. But let's go in more detail and let's use Cox regression. So you go on analyze, then survival, then Cox regression. Same thing, time to death in time, death in status, and smoking status in the curvites. And then we define smoking status as a categorical variable. It's very important to obtain the graphs. So smoking status, and you put first there as the reference category, and you need to go in the option of the Cox model, and you need to click there on the confidence interval, otherwise you will just have the hazard ratio and not the confidence interval of the hazard ratio. So the options are here, you just have to click there. And then in plots you need to click on check this log minus log, so it is for log minus log survival versus log time, but this will do. And then smoking status has to be placed here, and that's why you have to define before that it's a categorical variable, otherwise you won't achieve this part. You won't be able to put smoking status there. So log minus log, smoking status. And then we have our model. So here are the first part of the output. You have 1011 events with almost all the other patients being censored. But you have 7 cases with missing values still. Those are the association. You have the hazard ratio, it's 1.66, and you have the confidence interval right here. The p-value is here, it's less than 1 than 0, 0, 0, 1. So here is the log minus log survival versus log time graph. How to interpret this? It's very simple. You just need to verify that the curves are somewhat parallel. And this seems to be the case because really the distance between the two curves are very similar during all the follow-up. At the very beginning of the time of the follow-up, the curves are diverging quite abruptly, but it's normal to have at the very beginning of the follow-up curves that are not perfectly parallel, but soon after that you have parallel curves, so it seems that there is no strong interaction with time here. But let's use, even if it does not appear that there's a strong interaction, the Cox model with a time-dependent covariates. I will teach you how to do this. So you just have to put time, that is here. It's a different variable, you see. It's not the same icon than for the other variables. It's only available in the time-dependent Cox model. And you need to put this there in the t-curve. And after, you will model this t-curve. But this is without transformation, so linear variable, but you can introduce it in t-curve after a logarithm transformation, and you can also include it as a cutoff. So here the t-curve will be a time greater than 1 year, greater than 365 days. And after, when you choose one of those, you will go in model. And model, it's really like a standard Cox regression. The only different thing is that you have this t-curve that is not available in standard Cox model. And you will so define time to death as in time and death in status. And then you put smoking status. But in addition, you introduce the interaction between smoking status and the t-curve, that is either time, log of time, or time greater than 1 year. You have the same options, so you can to have confidence interval, and then you click OK to have the results, and here are the 3 results with the 3 variables you can obtain. First, time, so apparently there is no significant interaction with time being introduced as a linear variable. With log of time you don't have a significant interaction either. And at last, with time greater than 365 days, you also don't have a significant interaction. It's interesting to look at the hazard ratio, you see. During the second part of the follow-up, you have an increase in the hazard ratio that is of 22%. So you have a greater effect distantly from the beginning of the study, but it's not significant, the confidence interval across 1. Now, even if you don't have interaction, just to show you how to do it, I constructed 2 time-dependent variables, one for before 1 year and one for after 1 year. But you can do that in the standard module of time-dependent Cox model. You need to use a syntax. So the best way to go is to copy the syntax you have just above the output, in the result file of SPSS. You double-click on it, you copy it, and then you will paste it in a syntax file. So you click on File, New, then Syntax. You have a new syntax. You copy, and then you will modify this. This will be the nutshell for your new program. And in this syntax, you will be able to create 2 time covariates. So you need to put compute tick-off, different name, because before we had only one tick-off, so one name was okay, but now you need to differentiate those two variables. So I named it tick-off before 1, and the second one tick-off after 1, after 1 year. And this is smoking status, smoker 01, multiplied for the interaction by time less than 365. So that's the tick-off before 1, and the tick-off after 1, it's smoking status multiplied by time greater than 365. So the first variable is to have the hazard ratio during the first part of the follow-up, and the second variable, second tick-off variable, is to have the hazard ratio after the first time of follow-up. And then you have to change after the enter word to add your new tick-off. So you put tick-off before 1, tick-off after 1. If you want, you can say to SPSS that those are indicators, variable, categorical variables, but it's not necessary because you have a 0, 1 variable, so it's okay. And there, to have the confidence interval, you have to add them. And here is the output right here. So the hazard ratio for tick-off 1, so during the first part of the follow-up, is 1.57, and the hazard ratio during the second part of the follow-up is 1.92. Tick-off after 1, 1.92. Both are significant, and it is really in line with the results we had earlier, because remember that the interaction after 1 year was 1.22, and if you multiply 1.22 by 1.67, you will obtain something around 1.92. So if you have a strong interaction with time, with this, you will be able to provide hazard ratios for 2 different time of the follow-up, or even 3 different times of the follow-up if you want. So now you know almost everything, and let's analyze your data, and you can do it in SPSS. Have a nice day.